All right, so we're going to take a look at factoring using the difference of perfect squares. It's another type of technique that is really great to have in your factoring toolkit. You need to have a special situation, though, for difference of perfect squares to work. Difference means that you're subtracting, so that you need to be subtracting. You also need to be subtracting two things. So subtracting 2, and then you have to be subtracting perfect squares. So you have to be subtracting 2 perfect squares. So maybe we should think a little bit about what perfect squares are just for a second. So a perfect square is a number like 4 or 25, anything that you can easily take the square root of and get an integer answer. 64 is an example. Another example of a perfect square would be 1. So let's just list out a couple of them, just so we have those to look back at. So 1, 4, 9, I'll just do them in order here, 16, 25, and so on. So as long as I'm subtracting 2 perfect squares, I can use this pretty easy method. It's always going to follow this format. I'm going to start off with something squared minus something else squared, like in my first example here, x squared minus 16, and I'm definitely subtracting, right? Here I'm subtracting them, subtracting two things, the x squared and the 16, and both of them are perfect squares. I could rewrite them as the square root of something very easily. The square of 16 is 4, the square root of x squared is just x. So the next thing I want to do, once I've decided that I can use subtracting 2 perfect squares, is to write down 2 sets of parentheses. Those 2 sets of parentheses get filled with a plus and a minus. And then I take the square root of each of the 2 perfect squares. So the square root of x squared is just x and x. The square root of 16 is just 4 and 4. And there is my factored polynomial. Now I could just make sure that this works. So let's just show a check of why this works. So say I gave you x plus 4 times x minus 4, and I wanted you to FOIL that out. I should get x squared plus 16 as an answer. So let's see if that actually does work. X times x is x squared. X times a negative 4 is negative 4x. To my inside terms here, 4 times x is a positive 4x, and positive 4 times a negative 4 is a negative 16. So I've done all the multiplying. Now I need to combine my like terms. The negative 4x plus 4x just become a 0x. So they're going to cancel out, and I'm going to end up with x squared minus 16. Yeah, it really does work. So this is just a lovely shortcut if I have 2 terms that are both perfect squares. Let's try another couple of these. So 4x squared minus 25. I better go down my little checklist. Do I have 2 terms? Yes. Am I subtracting them? Yes, I'm definitely subtracting. There's the minus. And are they perfect squares? Are they something times something? Perfect squares. Yes, they are. 4x squared could really be 2x, right? And 25 is just 5. So I'm going to write down 2 sets of parentheses, a plus and a minus, and 2x, and a 5. And there is my factored polynomial. Let's try another one. Whoops, where'd it go here? 9x to the 6 minus 1. All right, go down the little checklist. Do I have 2 terms? Yes, I have 2 terms. So 9x to the 6 minus 1. Am I subtracting? Yep, I'm subtracting. And now I want to know, do I have perfect squares? Well, it might look like I do, but then I've got some weird stuff. So for sure, the 9 is a perfect square. That would be a 3, right? 3 times 3 is 9. And 1, that's kind of weird, but yeah, the square root of 1 is just 1, so I know that's a perfect square. But what about this x to the 6th, this part right here? Let's think about that for just a second. Okay, to be a perfect square, that means that I can rewrite something as something times itself. So what times itself would give you x to the 6th? Let's think about that. So it would be x times x. And, if I had x cubed times x cubed, well, remember that if the bases are the same, our exponent rules tell us to add the exponents together. So that would be x to the 3 plus 3, which is indeed x to the 6. So I think I'm good to go. I think I definitely have perfect squares. All right, let's finish this problem. So I am going to write down 2 sets of parentheses. And then I'm going to write down a plus and a minus. And then I'll take the square root of both of those terms. So the square root of 9x to the 6 is 3x cubed. I write it in both parentheses. And then the square root of 1 is just 1. And there's my factored polynomial. Yay! All right, one more kind of tricky looking one. All right, once again, I go down my little checklist. Do I have 2 terms? Yes, I do. I've got a 36x squared. I've got a 100y squared. Am I subtracting? Absolutely. There it is. I'm subtracting. 2 terms subtracting. Now, the only other thing I need is that they both have to be perfect squares. All right, well, let's see. 36x squared. Yeah, that's a perfect square, right? Because I could take the square root of that. I get 6 and an x. What about that 100y squared? Well, 100y squared, 100, well, that would be 10 times 10. And then the y squared, that would just be a y. So it looks like I have perfect squares. 2 terms, they're being subtracted, they're both perfect squares. My difference of perfect squares should work. Let's see what that looks like. Write down 2 sets of parentheses. It's a plus and a minus. And then I'm going to take the square root of both the terms. So 36x squared, that's just 6x. I write it in both spots. Here's the part that some people get worried about, the 100y squared. So most people will say, yep, it's 10 and 10, but what about the y squared? Well, just like the x squared, I split up the y into 2 spots. So my factored polynomial is going to be 6x plus 10y times 6x minus 10y. Yay, that one is done as well. All right, the last thing that I want to do is just to show you some non-examples. Some times when the difference of perfect squares doesn't work. The difference of perfect squares won't work. So basically, when I go down my checklist, something about the checklist fails. So let's see. How about this one? 36x squared plus 4. Well, do I have 2 things? Yep, I've got a 36x squared and a 4. Am I subtracting them? No, I'm not subtracting them. Look, I'm adding them. I do have perfect squares. 36x squared could become 6x and 4 could become 2, but because I am not subtracting, I can't use the difference of perfect squares. It won't work here. So, won't work. No subtracting. Let's try another one. How about this one? 6x squared minus y. Well, let's do better than y. How about minus 25? All right, go down the checklist. 2 things? Yep, 2 terms. Subtracting? Yep, I'm subtracting this time. Do I have perfect squares? Oop, nope, I don't. 25 is a perfect square. X squared is a perfect square, but 6 is not a perfect square. 6 is 2 times 3, not something times itself. So this doesn't work. There are no perfect squares, or not all perfect squares, probably, I should say. Not all perfect squares. Let's try one more non-example. How about this? 100. Yeah, there we go. 100 x to the 7th minus 16. All right, go down the checklist. Are there 2 terms? Yep. 100 x to the 7th and 16. Am I subtracting? Yep, I am subtracting those 2. Do I have perfect squares? Well, let's see. The square root of 100 is 10. The square root of 16 is 4, but that x to the 7th, am I going to be able to split that up into x times something and x times something and have it be the same something? I don't think so, because it would be 3 and 4, right? That would give me 7. That won't work. So I'm afraid this is also not going to work for difference of perfect squares. And it's because there are not all perfect squares. All right, I'll stop here, and the next video will be another factoring trick.